over 109 million people of today were the estimated count in the Philippines. This is somehow a rough shift in population because just between 2010 and 2020, the Philippine population growth rate was just about 1.72%. And a country or a region with a large number of population will possibly experience overcrowding, waste and housing issues, pollution, and other undesirable phenomena. Therefore, the study GIS-based spatial analysis on the changing demographics, population outgrowth or regression in Agusan will be carried out as one of the first steps on starting to change the way we used to live. It will establish a platform of awareness, information, and education concerning population shift or transition, which will demonstrate importance of population control and effective distribution to specific areas considered as rural or urban, not just within the province, but also throughout the region within the Philippine border. Now, this paper will systematically examine population change, influential factor as well as their temporal and spatial and dynamics using GIS-based approaches such as GIS scatter plotting or ordinary least square regression analysis and modeling. This study provides a more dynamic and a less biased estimates of the effects and a more comprehensive understanding of the population change. So the main objectives of this study is to show the analysis via regression model of this study area wherein there is population growth or regression happening in that particular place. So here's how it will be conducted. From the data collection and processing, which will be discussed later, to the exploration of the cause and effect relationship and the development of the models and GIS-based maps. And here's how the data collection and processing phase will be initiated. First, when the PSA population census or PAPCEN permits the researchers to use existing data files in population or population demographics or population count, will the data acquisition and processing phase begin. These gathered data in population and its corresponding influential or spatial factors, termed as the variables, will be stored in the GIS database management. It will undergo manipulation and analysis, then an OLS regression will be run. Let's put the GIS regression tool in action by building a spatial factor index, also known as resource selection function or RSF. With the GPS location of the people, we will investigate the relationship between the population and their corresponding driving factors. We answer questions like which spatial factors do population change select or avoid? What are some of the factors that contribute to the location of people that affects the changes? Are there any land areas that potentially disturb in the cause that the other place is growing while the other place is declining? And in working with ordinary least square regression or OLS, the first step is to group the independent and dependent variable per grid cell. We can look at the people's location at points. We will create a table that will show the number of people and their corresponding factors that made them count as such, maybe declining from the previous count or maybe growing from its previous count from the previous census. After running the OLS tool, the residuals of the prediction model will be added to the display. The residuals are essentially the error in the model, and the spatial regression tool was used to build a spatial relationship between the spatial factors and how it drives to change the population count in that area, whether it is growing or decreasing. Regression tool will investigate the relationship between these factors and will generate weights for each variables. And these possible outcomes will be an aid to many government agencies, especially in the development sector as part of their development plan that regards the accountability of population change, population distribution. It may changing demographics. It may be growing population or declining population. And that would be all. Thank you.